Hello everyone, welcome to this lecture video. In this lecture video, we are talking about the operating system concept swapping. In the unit 3, we are having the memory management concepts. In that, we are having the swapping process. Swapping is a process that what we start with swapping. In this swapping is a process temporarily out of memory to a backing store and then brought into a memory for continued execution. So backing store fast disk large enough to accommodate copies of all memory images from all users must provide direct access to these memory images. Rollout and roll in swapping when used for priority based scheduling algorithm. Lower priority process is swapped out of so higher priority process can be loaded and executed. So major part of the swap time is transfer time. So total transfer time is directly proportional to the amount of memory swapped. So modified version of swapping are found on many systems. Example Unix, Linux and Windows. So this is a schematic view of swapping. Operating system we have the process 1, process 2, swap out and swap in the swapping. So in that we have the process 1 will be swapped out, process 2 will be swapped in. The user space and backing storage will be stored in the storage place, and the operating system we have the in the memory main memory having the OS concepts. It inbuilt of the memory integrated with the main memory. The user space will be allocated to the operating system. In that we have the swap out and swap in. Process 1, process 2 we having the process of swapping. In that this is about the swapping. Next we have contiguous allocation. In the main memory we have the in this continuous allocation we have main memory used usually into two partitions: resident operating system and other things. So single partition allocation, reallocation register scheme used to protect user process from each other and from changing the operating system code and data. So reallocation registers contains value of smallest physical address. Limit registers contain range of logical address. Each logical address must be less than the limit registers. Then hardware support for the reallocation limit registers here. In this picture we can have the hardware support and other reallocation limit registers. So CPU we can have the logical address and physical address, and the limit registers we can have the following values. So physical address main memory, the trap address limited registers reallocations. So this is about the hardware support for the reallocation and limit registers things. So in the continue to this we have the continuous memory allocation. In the multiple partition allocation we have whole and other things. We have when a process arrives with allocated memory from a whole large enough to accommodate it. So in the operating system we have the process 5, 8, 2. It will be sending the process to other process 5 and 2. In the picture we can able to see the things how the whole and operating system allocation partition, free partition, how it's working. So multiple partition allocation, block of available memory, holes of variable size are available or scattered throughout the memory. So in this we have the dynamic storage allocation problem. So how to satisfy the request of size and from a list of free holes. First we have the first bit and best fit and worst fit. We have the three things. First fit you have to allocate the first hole that is big enough. And the second thing we are talking about the best fit. It allocates the smallest hole that is big enough, must search entire list unless ordered by size. Produces the smallest leftover hole. And worst fit allocate the large hole, must allocate also search into entire list. Produce the large leftover hole. The first fit and best fit better than the worst fit in terms of speed and storage utilization. In this have this fragmentation. In the external fragmentation, total memory spaces extends to the satisfy a request, but it is not a contiguous. So internal fragmentation, it allocated memory may be slightly larger than the request memory, then the size differs in memory into a partition but not being used. So reducing the external fragmentation by compaction. So shuffle memory condense to place all free memory together in these things. So next thing is paging. We start with the paging. We have the logical address space of process can be non-contiguous allocation. So process is allocated by the physical memory whenever the latter is available. So here it can be divided physical memory into a fixed size of blocks called frames. We are most familiar using the term frames. It is nothing but frame is a divide the physical memory into a fixed size blocks that called as frames here. So size of power of 2 between 512 bytes to 8192 bytes. So this thing is a divide logical memory into blocks of same size called as pages. So dividing the logical memory into a blocks with the same size that we call as pages. So keep track of all free frames. So to run the size n pages, need to find n frame and load program. So set up a page table to translate logical to physical address. So internal fragmentation. So address translation scheme, CPU divided into page number P, page offset D. So use it into index page table with contains the base address of each page in your physical memory. The page combined with the base address to define physical address that is sent to the memory unit. Then address translation architecture. We have the CPU, a logical address and physical address. We can have the page table. So physical memory we can having these kind of things. In address translation architecture, we having this kind of process. So logical address, physical address, we can have the page table. So we are following the physical memory and CPU. So the next with the paging example, we could be able to see in the schematic picture of paging example, logical memory and physical memory and the frame numbers process here. So this is about the paging. We can see thanks for watching this video. We can able to understand what is paging and other thing, basic concepts of operating system concepts in the memory management. Thanks for watching. Thank you.